Okay, so I thought I'd try to draw some things on this to explain it a little bit. So a horizontal stretch. There's an example in the book, but one of the problems with the horizontal stretches and compressions, it's a little hard to see that they're stretching horizontally unless they give you like a graph or something that's a little bit different, not one of our toolkit functions. Later on, when we do trigonometric functions, you'll be able to see the horizontal stretches and compressions a little better. But so I'm going to do an example that's not in the book. You can look at the book though as well. Let's say we have some function. I'm going to try to make it really simple here. Let's say 1, 2, 3, 4. Let's say there's a point at 2, 4, a point at 0, 0, and then we'll say 1, 2, 3, 4, 5, 6, 2. Okay, so this point here is 0, 0. This point here is 2, 6. No, 2, 4. Sorry. And then, you know what, I'm going to change that last point. Sorry. It's going to be huge if I do a stretch first. Okay, let's say this point is 3, 2 right there. Okay? 3, 2. And so the graph, I'm just going to make these straight lines so it'll be a little bit easier for you to draw and stuff. Let's say that's our function. Okay? Well, what happens when we stretch it then is it would be then 4, 4. So the 0, 0 would stay. 1, 2, 3, 4, 4. So like this point would go twice as far over. Okay? And then it would be 3. It'll be 6, 2. So it's going to be over here. So this point would be 6, 2, and this point here would be 4, 4. And then the graph would look like this. That would be an example of a horizontal stretch. Okay? All right. We'll talk about how this looks at the formula in a minute. Now let's say we had the same function. Let's see, it was 1, 2, 3, 4, 5, 6. Okay, so we had the point 2, 4 originally, and the point 3, 2 right there. And we had a function like this. Okay, now when we want to do a compression, what we want to do, let's say we're going to cut it in half. Then my point that used to be at 2, 4 is now going to occur at 1, 4. So it's coming in, it's going like this. The point 0, 0 is going to stay 0, 0. And then the point that was at 3, 2, well, that's going to scoot into 1.5, so 1.52. So it's going to be like right there, 1.52. So then my compressed graph would look something like that, okay? So see how the points are getting closer to the y-axis. So this would be a horizontal compression. Now that's just looking at a random graph that I made up. Now what we have to think about though is the notation, okay? So let's say that my original function here was f of x. Now I'm going to write what g of x is. G of x, it has to do with the input, right? So the outputs were staying the same. So when I went from here to here, notice that I doubled the output, right? Okay, so what do I have to do to make that happen? It's kind of like we're going the other way. How can I get f of 2? I'd have to take this 4, this one right here, and cut it in half. So g of x is going to equal f of x, oops, no, f of 1/2 x. Now, that's usually tricky for students to understand, so let me see if I can explain it better. See this point here at 4, 4? I want to put in a 4 here, but I want to get out the point, I want to get this output of 4. So I have to have this somehow look like a 2, right? I'm putting in a 4 for x, but I want to find f of 2 because that's what gives me a 4 output. Okay, I'll explain this again. All right, and then let's look and see what happens here. So if I put in a 6, so put in a 6 for x, half of 6 is 3, and then I get the output, f of 3 is 2, and that was the output I wanted. Okay, it's kind of like back when we were saying you have a horizontal shift, so it was x minus c, but this is going to be divided by. It looks like you're multiplying it because you're stretching it, but you're actually dividing those inputs in half to give you what the output is in the original function. You may have to let that marinate for a little while. You may have to watch this video again. Okay, but that's how that one works. Now let's look at the compression. So it's going to be very similar. Let's call this green thing h of x. Okay, and this was f of x. Okay, so h of x, it's probably doing what you think it's going to do. You're going to find f of 2x. Okay? Because what's happening? For this point right here, that point in green that is 1, 4, I'm putting in a 1, but I want to know f of 2. So I put in a 1, that's going to say f of 2 times 1, or f of 2. But I know from the original function what f of 2 is. That is 4. So that gives me an input of 1 and an output of 4. Then you can do the same thing with putting in a 1.5, right? So you put in the 1.5, f of 2 times 1.5, and that's going to give you f of 3. And we know f of 3. You have to go back to this point right here. F of 3 is 2. So that's how we get that output of 2. So maybe it made a little more sense doing that one. So let's hope. That was that. And for the other one, this was the formula here. So I'm just trying to explain it to you. I know it's a little bit confusing. Like I said, you might have to watch it again. You can also look at the example in the book. They use a quadratic function, so that might be a little easier to think of. I was going to do that real quick. So say you have y equals 1/2 x squared. Okay, you know that in the original, f of x equals x squared. You know that if you put in 2 for x, you'd get out 4, right? Okay, so if I want this to be a 2, what do I have to put in? I have to put in a 4. So for my table of values here, for this function here, x and y, I just used x and y. If I put in a 4, that's going to get me an output of 4. Okay, so that's why it's going to be a stretch. Okay, so anyway, you can look at that in the book as well. But here comes the rule. So if you have g of x is equal to f times, they don't use c this time, they use b, so I'll just put in a b. But if that absolute value of b is greater than 1, then it's going to be a compression. And that's what might be a little bit tricky to think about. If the absolute value of b is greater than 0 but less than 1, that's when it's going to be a stretch. And if b is negative, then it's going to do a reflection and it's going to have a compression or a stretch. Okay,